In this video, we are going to talk about coordinate geometry. I am sure that you have seen something like this. This is actually a graph and this is our x-axis and this is our y-axis. Now, suppose we are interested in finding the position of a point in a graph. Suppose then we are having something like this. This is our x-axis, this is our y-axis, and we are having a point here. So, to determine the position of a point in a graph, we need two numbers. Actually, we need ordinate and abscissa. Now, what are those? That is, what are ordinate and abscissa? Now, to determine the position of a point from the origin, we need its distance along x-axis and along y-axis from the origin. Now, the distance of the point from origin along the x-axis is represented by this dashed line, and let's say this distance be a. Now, similarly, the distance of this point from origin along the y-axis be something like this, and let's say this distance be b. So, the position of this point is represented by a, b. Now, suppose we are interested in finding the distance between two points in a graph. Then we will be using something known as distance formula. Here we are interested in finding the distance between the points A and B. Here the coordinates of A is x1, y1 and coordinates of B is x2, y2. So if we see carefully in this graph, then we can see that triangle ABC is a right angle triangle. So we can easily find the length of the side AB using the Pythagoras theorem. So for that we first need the length of the sides AC and BC. So how we will be finding those two sides? So as we can see from the graph, our AC is equal to x2 minus x1. Now this red line is showing the distance of x2 and this blue line is showing x1. From these two lines, we are seeing that our x2 minus x1 represented by this violet line, which is equal to AC. Now we can do similar reasoning for BC, and we may obtain BC is equal to y2 minus y1. So here we have found both the sides AC and BC. So now, as the triangle ABC is a right angle triangle, so AB square is equal to AC square plus BC square. This is basically Pythagoras theorem. Now let's use the equation 1 and equation 2. Then we will be getting something like this. That is, AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now we have obtained this using equation 1 and equation 2. So the distance between any two points A and B is given by this formula, and this formula is known as the distance formula. So let's put all this together. That is, if we have two points A and B where the coordinates of A is x1, y1 and coordinates of B is x2, y2, then the distance between these two points is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, suppose we are verifying the distance formula with the help of an example. Suppose we want to find the distance between these two points, that is A 1, 2 and B 3, 4. So, according to the distance formula, we are having the formula something like this, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So we are putting the values in this formula. We are getting in square root of 3 minus 1 whole square plus 4 minus 2 whole square. On simplifying it, we are getting square root of 2 square plus 2 square. On simplifying it further, we are getting square root of 4 plus 4. On simplifying it further, we are getting square root of 8, which is 2 into square root of 2. So this is the distance between A and B according to distance formula. Now let's talk about section formula. Suppose we are having 2 points A and C, where the coordinates of A is given by x1, y1 and coordinates of C is given by x2, y2. Now, as we can see from the graph that here the triangle ADB and triangle BEC are similar because all of the angles are equal. Now, let's assume that the ratio of the distance AB by BC is equal to M1 by M2. So, as the triangles are similar, then we will be getting AB by BC is equal to AD by BE is equal to DB by EC. Actually, these are the ratio of the sides which are equal because the triangle ADB and triangle BEC are similar. So, what we are getting in is AB by BC is equal to M1 by M2. This is something which we have assumed, and we are also getting this, that is AB by BC is equal to AD by BE is equal to DB by EC. This is there because the triangle ADB and triangle BEC are similar. So, from this we may write, using the graph, we can see that AD is equal to x minus x1, and again from the graph we may see that BE is equal to x2 minus x, and we can see DB is equal to y minus y1, EC is equal to y2 minus y. So, from using these formulas, we can write M1 by M2 is equal to x minus x1 whole divided by x2 minus x is equal to y minus y1 whole divided by y2 minus y. So, we are having M1 by M2 is equal to x minus x1 whole divided by x2 minus x is equal to y minus y1 whole divided by y2 minus y. Now, let's consider the first two expressions, that is M1 by M2 is equal to x minus x1 whole divided by x2 minus x. Now, on simplifying this, we may write M1 whole into x2 minus x is equal to M2 whole into x minus x1. Now, we will be basically solving this for x. Then, on simplifying, we are getting something like this, M1 x2 minus M1 x is equal to M2 x minus M2 x1. On further simplifying, we are getting something like this. Basically, we are putting all the terms associated with x along the right hand side, and then we are getting, on further simplification, M1 x2 plus M2 x1 is equal to M2 plus M1 whole into x. So, from this we can easily see that x is equal to M1 x2 plus M2 x1 whole divided by M1 plus M2. Now, we can do this similar thing for y. So, now considering the first and the third term, we are having M1 by M2 is equal to y minus y1 whole divided by y2 minus y. So, now we will be solving this for y, and on simplification we are getting in something like this, that is M1 y2 minus M1 y is equal to M2 y minus M2 y1. So, now we will be putting all the terms of y along the right hand side. Then we will be getting M1 y2 plus M2 y1 is equal to M2 y plus M1 y. Now, on solving this for y, we will be having y is equal to M1 y2 plus M2 y whole divided by M1 plus M2. So, here basically what does this section formula means is that the point B is actually a point which is dividing the line segment AC in the ratio of M1 by M2. That is, B is a point such that AB by BC is equal to M1 by M2. Actually, section formula is used to find out the point B, for which this is the ratio. Or we may do the sum in the reverse order, that is, we have the point B and we will be trying to find out the ratio. Now, let's talk about the area of a triangle. Suppose we have a triangle A, B and C, and we want to find out the area of this triangle, and also here we are given the coordinates of A, B and C. That is, coordinate of A is x1, y1, coordinate of B is x2, y2, and the coordinate of C is x3, y3. Now, until now, we haven't discussed any direct formula to find out the area of this triangle. So, what we have to do is that we have to somehow derive a formula. Actually, what we will be doing is that we will be considering 3 trapezoids, and then from the area of those 3 trapezoids, we will be getting the area of this triangle. So, let's get started. Suppose we are considering a trapezoid something like this. Here we must see that the points A and B are the same points from the triangle, and what we are doing basically is that we are drawing a vertical line from A to the x-axis, and we are doing similar thing for B also. So basically what we are getting is that APQB, which is a trapezoid. The parallel sides are AP and BQ. So basically we will be finding the area of this trapezoid, that is H into A plus B whole divided by 2. Actually here H refers to the perpendicular distance between the parallel lines. Here our H will be the distance between P and Q, and A and B are the length of the parallel sides. Here one of the parallel sides is AP and the another parallel side is BQ. Now our H is equal to x2 minus x1, and here from the graph we can see that our A is equal to y1 and B is equal to y2. So now we have got all of our unknowns, that is H, A, B. So now we can easily put these 3 values into the formula and evaluate the area of the trapezoid APQB. So we are getting area of the trapezoid as follows: x2 minus x1 into y1 plus y2 whole divided by 2. Now we have found the area of the trapezoid APQB. Now we need to do this same thing for 2 more trapezoids. Now let's consider the next trapezoid, that is this. So here we will be finding out the area of the trapezoid BQRC. Here once again, the formula to find out the area of the trapezoid is this, that is H into A plus B whole divided by 2. Here our H is x3 minus x2. Here the perpendicular distance between the 2 parallel lines is basically QR, and also the length of the parallel sides are A is equal to y2 and B is equal to y3. So here the area of the trapezoid BQRC is equal to x3 minus x2 into y2 plus y3 whole divided by 2. Now we are left with a last trapezoid, that is this APRC. Here once again we must note that this AC line is the same line of the triangle. So here once again we will be finding out the area of this trapezoid, that is we will be using the same formula, that is H into A plus B whole divided by 2. Here H is equal to x3 minus x1, which is basically the length of PR, and our A is equal to y1, our B is equal to y3. So the area of this trapezoid APRC is equal to x3 minus x1 whole into y1 plus y3 whole divided by 2. So if you remember, we have actually found out the area of the 3 trapezoids. Now let's try to put these 3 trapezoids together. This is our last trapezoid, then we are putting in this trapezoid and then this trapezoid. Now if we see carefully, actually we have the triangle A, B and C. Now if we add the area of the trapezoids A, P, Q, B and B, Q, R, C and then subtracting A, P, R, C, then what we will be left with is the triangle ABC. So Let's try to put this together. So area of our triangle ABC is equal to area of APQB plus area of BQRC minus area of APRC. As we have derived the formula for each of these three trapezoids, so we will be putting those three formulas into this formula. That is something like this. Area of the triangle ABC is equal to x2 minus x1 whole into y1 plus y2 whole divided by 2 plus x3 minus x2 whole into y3 plus y2 whole divided by 2 minus x3 minus x1 whole into y3 plus y1 whole divided by 2. Now we will be basically simplifying this formula of the triangle ABC. So we will be having something like this. Then on further simplifying, actually we are opening up the brackets and then multiplying the corresponding terms, we can simplify it further. Then we will be having this. And now finally we will be arranging this area of the triangle ABC into something like this. That is x1 into y3 minus y2 plus x2 into y1 minus y3 plus x3 into y2 minus y1 whole divided by 2. Now one thing we must note that this formula which we have derived might be different from what we usually found in the books because of the different naming order of the vertices. Thank you for watching.